Welcome to our show, A Window to the Cosmos, the Hubble Space Telescope's 30-plus year journey, part 1 of 2. For centuries, humanity has gazed at the stars, wondering about our place in the universe. Traditional telescopes help us to see the unknown. However, our atmosphere distorts light coming from space, so looking at objects in space through the atmosphere is like looking through moving water. Moving telescopes from Earth into space finally solved this problem. The Hubble Space Telescope, or Hubble, has fundamentally changed how we observe the universe. Dr. Edwin Hubble was an American astronomer famous for revolutionizing how we see the universe. He discovered that galaxies exist outside our Milky Way and that the universe is expanding. The United States National Aeronautics and Space Administration, or NASA, named the Space Telescope after him to honor these groundbreaking contributions. First conceived in the 1940s as the Large Space Telescope, Hubble was launched on April 24, 1990, after decades of planning and research. Despite early challenges, it has performed innumerable scientific observations, from estimating the age of the universe to tracking changes in the celestial bodies in our solar system. Let's explore how this incredible journey began. The 5 NASA astronauts aboard Space Shuttle Discovery completed their 5-day mission to deploy Hubble to its assigned orbit around the Earth. At 13.1 meters long and 4.3 meters wide, the Hubble Space Telescope is about the size of a school bus, and it has a mass of about 11,110 kilograms. It orbits the Earth at a height of 547 kilometers and moves at 7.5 kilometers per second, completing one orbit of the Earth every 95 minutes. Shortly after launch, scientists found a problem with Hubble's main mirror. The edge of the mirror was a tiny bit too flat, making the telescope's images blurry. Fortunately, being in low Earth orbit, Hubble was the first space telescope designed with servicing in mind, so astronauts could return to Hubble to make repairs. In 1993, they installed corrective optics, like putting glasses on Hubble to help it see clearly. The ability to service Hubble would prove crucial throughout its lifetime, especially when it came to maintaining its navigation system. Hubble can be moved by 4 internal reaction wheels with a mass of about 45 kilograms each. When these wheels spin in one direction, the telescope rotates in the opposite direction. This effect is famously known as Newton's third law of motion. The wheels are positioned at different angles, allowing Hubble to rotate along any axis. It takes about 15 minutes to turn 90 degrees.
While we're turning Hubble, we need to know exactly which direction we're turning it. So we use a sensor known as a gyroscope, or a gyro. They use the conservation of angular momentum to tell us if Hubble is turning in which specific direction and how fast it's turning in that direction.
The Hubble Space Telescope has had 5 servicing missions since its launch in 1990. The pointing system needed 3 active gyros. In 1999, the 4th of 6 gyros failed. NASA declared a Hubble emergency and split Servicing Mission 3 into 2 parts. Servicing Mission 3A to replace 6 gyros, and Servicing Mission 3B for less urgent updates. Hubble needed a reliable power source to operate continuously in space. Being free from cloud cover, satellites are ideally suited to using solar power, and Hubble has 2 large arrays of solar panels, each 7.1 meters long and 2.6 meters wide. Besides powering the telescope, they also charge 6 batteries, which are used while Hubble passes through the Earth's shadow, which occurs for about 36 minutes in each 95-minute orbit. At the heart of Hubble's capabilities are its sophisticated imaging instruments.
As a cosmic photographer, NASA's Hubble Space Telescope has taken over 1 million snapshots documenting the universe. These images illustrate, explain, and inspire us with their grandeur, but may not match what we'd see with our own eyes. That's because Hubble sees light beyond our sensitivity. Our eyes only sense a small fraction of the universe's light. This tiny band of wavelengths, called the visible spectrum, holds every color in the rainbow. Light outside that span, with longer or shorter wavelengths, is invisible to our eyes. But those invisible wavelengths can tell us so much more about the universe.
In order to keep these instruments at peak performance, NASA continued improving Hubble through its final servicing mission.
Now, you see the Wide Field Camera 3. This instrument was upgraded on the last servicing mission to Hubble and is the most technologically advanced instrument on board. Coming to the top of the telescope, you can look down and see Hubble's 2 mirrors, which are made of special glass with reflective coatings. The large primary mirror collects cosmic light and reflects it to the secondary mirror. The secondary mirror bounces the light back through the hole in the primary mirror and into the telescope's instruments.
During servicing Mission 4 in 2009, astronauts installed advanced scientific tools. The Wide Field Camera 3 captures detailed images in various wavelengths, while the Cosmic Origin Spectrograph analyzes ultraviolet light from distant objects. Astronauts also successfully repaired older instruments that had stopped working. Fixing the Space Telescope Imaging Spectrograph, or STIS, was a remarkable feat of space engineering. It had not worked for 5 years. The repair required astronauts to remove a cover plate with over 100 tiny screws. This task was never intended to be done in space. Wearing bulky space gloves, they needed exceptional dexterity and patience. A single mistake could have been dangerous. After years of training, they successfully completed this delicate procedure. But this wasn't the only obstacle the astronauts faced. On servicing Mission 4 in 2009, a stubborn bolt complicated the installation of the new camera. During the STI's repair, a stripped screw locked a handrail place, blocking crucial access. With real-time support from engineers on Earth, astronaut Dr. Mike Massimino improvised a solution by breaking the handrail free by hand, allowing the repair to continue. This was Hubble's final servicing mission, as the Space Shuttle program was ended in 2011. We would like to thank all the engineers, scientists, astronauts, and support teams for their ingenuity and dedication, which have created this lasting legacy of expanding our cosmic horizons. Welcome to our show, A Window to the Cosmos, the Hubble Space Telescope's 30-plus year journey, part 2 of 2. In the first episode, we shared the history and purpose of the Hubble Space Telescope. Today, we will explore how Hubble's images are created and how they have contributed to advancing our understanding of the universe. With such an enormous sky filled with countless fascinating objects to study, you might wonder who decides what Hubble should look at. Scientists around the world submit competing research proposals, which are evaluated based on scientific merit by a committee of 150 experts from the Space Telescope Science Institute in Baltimore, Maryland, USA. 10% of telescope time is reserved for the director's discretion, which has led to some of Hubble's most famous discoveries, including the deep field images. In some ways, telescopes are time machines. When Hubble gazes deep into space, it collects light which has been traveling for billions of years, carrying with it information from the distant past. For example, in 1995, scientists aimed Hubble at a tiny, seemingly empty patch of sky near the Big Dipper. After 10 days, an astonishing image emerged, the Hubble Deep Field. It revealed over 3,000 distant galaxies from nearly 10 billion years ago.
Hubble's accomplishments include something called the deep fields, looking out into space and collecting light, sometimes for many days. These deep fields have revealed visually to us a universe absolutely teeming with galaxies, hundreds of billions of galaxies.
There's a very, very long exposure time. But probably what's more important is how many orbits it took us to do that. 400 orbits of Hubble data to take that image. You only get 15 orbits a day. To take 400 orbits and say, we're going to observe this one spot in the sky for 400 orbits. And the really unique thing about that was they picked a spot where there wasn't anything. They looked and they said, there's absolutely nothing here. And they said, you want to spend 400 Hubble orbits looking at nothing? And they said, yes, because we want to see what it can see. And I think the results from the science, it was amazing. What they saw was spectacular.
The colorful images we see from Hubble start in black and white, and scientists add color to show light emitted by different elements like hydrogen, oxygen, and sulfur, which is otherwise invisible to the human eye.
Hubble's most famous example of this is called the Pillars of Creation, which captured huge towers of gas and dust forming new star systems. It's more of a colorized map. Hydrogen and sulfur are both seen naturally in red light, and oxygen is more blue. Coloring these gases as we'd actually see them would produce red, red, and cyan, and the Pillars of Creation would look more like this. Not as useful for visual analysis. In order to get a full color image and visually separate the sulfur from the hydrogen, scientists assign the elements to red, green, and blue according to their place in the chromatic order. Basically, that means that since oxygen has the highest frequency of the three, it's assigned blue. And since hydrogen is red but a higher frequency than sulfur, it gets green. The result is a full color image, mapping out the process by which our own solar system might have formed.
Hubble also demonstrated Dr. Albert Einstein's vegetarian's theory of gravitational lensing, the bending of light as it passes a curved region of space-time created by massive objects.
Einstein predicted that mass distorts space, but we didn't realize we could actually see the effects of that. But with Hubble, we have been able to see distortions in space around clusters of galaxies. The way we see that is when light from a background galaxy travels through that cluster of galaxies or around it due to this gravitational lensing effect. The lensing also magnifies that background galaxy, so if we look in some of these distorted arcs, we can see more detail than we would ever have been able to see without gravitational lensing, nature's boost.
Another revolutionary discovery came in the late 1990s, when observations of distant supernovae showed that the universe's expansion is accelerating. The cause of this unexpected finding remains one of cosmology's greatest mysteries, and scientists proposed a new type of energy, known as dark energy, to explain this phenomenon. In 2012, the Extreme Deep Field, or XDF, was created by combining images from two advanced cameras, and it found around 5,500 galaxies, with the youngest dating back to just 450 million years after the Big Bang. In 2022, Hubble detected Earendel, the most distant individual star ever observed at that time. The light from Earendel had traveled for 12.9 billion years, providing astronomers with data about stars that existed when the universe was less than a billion years old. Through 5 servicing missions until 2009, astronauts performed crucial upgrades to Hubble's instruments. Since 2021, Hubble has operated in one gyro mode to extend its lifespan. While less efficient, this adaptation is expected to allow the telescope to continue operation for over 3 decades. The James Webb Space Telescope was launched in 2021. Hubble's ability to detect visible and ultraviolet light complements Webb's ability to detect infrared light, which has longer wavelengths than what Hubble can see. Both telescopes continue to advance our discovery of the universe.
We as humans have developed or been granted the ability to develop instruments that enable us to see far beyond what the human eye alone could ever see, and to think about what it means, to think about how we on this planet relate to star systems far beyond our own. I think that's wonderful. It should make us all feel a sense of gratitude and humility, and also connectedness.
Scientists have shared many stunning images captured by Hubble and other space telescopes. These images spark curiosity about young stars, galaxies, and black holes, with photos showcasing various colors and lights. Our most beloved Supreme Master Ching Hai, vegan, graciously shared with us the profound insight into the spiritual significance of black holes and the colors of light such as red, golden, and white.
Nowadays, the scientists are phenomenal. They even can take that photograph from thousands or hundreds of thousands or million light years away.
Yes.
It's incredible already. It's just the meaning they do not understand, but they see the photo. Okay, they can take the photograph. This is already very, very, very miraculous. Very miraculous for me. I feel they are awesome. There is energy. Aggressive energy. It manifests as the red light, okay? Just a red bunch of energy, red. And the golden one that added onto it, that is a rescue refugee camp. Oh. Yeah, when the hell person is rescued and brought up there first, like a convalescence, like to recover for a while first, before they can go further anywhere else, higher up.
Yes.
Just like you're sick, okay? The health person, when they come up, they're still sick. They're still not normal because of so much suffering, so much frightening experience, so much torture for their psyche. They don't have the physical body, but their astral body feels pain, scared, fearful, just the same.
Yes, Master.
So that golden light is a refuge area for them to recover. Outside of that red zone, okay? The black hole is black inside, but outside, because their energy is so strong, it bursts forth out like a red ring around it. The golden and the white are the souls who have been pulled out. Wow. Okay? And the blue, it depends on what kind of blue. Also, maybe these are from the saints. They pull them out. The light of the saints, the light of heavens, that pull these souls out, rescue them.
We are grateful to our most compassionate Master for sharing her enlightening insights, helping us to gain a clearer understanding of the universe. As we conclude our journey through Hubble's achievements, we extend our gratitude to the innovative engineers, scientists, astronauts, and other international teams who made this remarkable telescope possible. Their dedication keeps the spirit of discovery alive.
Turn vegan? Congratulations for joining the Noble Club. Thank, love, remember the reunited three most powerful one, God, Timbuktu, and the Son of God.
Cherished viewers, it has been a pleasure having your company today. Please stay tuned to Supreme Master Television. May God bless your noble actions with peace and spiritual upliftment.
Being vegan, having peace, heaven Godspeed.